Hello, students. Welcome to the guided study for Learning Target D8. Today, we are going to do two examples of mixing derivative rules. I have put at the top of the paper here the list of rules that could be useful when studying for Learning Target D8. This is not an all-inclusive list. Please make sure that you also go back and look at all of the rules from Learning Target D4 and Learning Target D6. Remember that these build, and if you don't feel confident at this point using individually the product, quotient, and chain rules, you need to go back and review those sections. I have added into the guided study 3 additional videos that review each one, product, quotient, and chain. They do some basic examples of the product, quotient, and chain rules. So go back and get more comfortable with those 3 rules. And really, if you're not comfortable with the power rule, then you need to go back to D4. This stuff was D5. This was D4. And this was D6. And there were some other rules in D6 that you do need to write and know. But for now, these are just kind of some of the basic ones so that I could throw them up on the screen. You could see them nice and pretty all together. I also encourage you, when combining derivative rules, write these down. I also recommend that you practice really good work organization, modeling your solution technique after the way I write the solutions below. And yes, I tend to overwrite things. I tend to write too much, possibly much more than you will need as you become more confident in these rules. But when you are first learning these, if you take the time to do this, not only will you learn it quicker, but it'll be easier for you to find any mistakes that you might make as you go. So let's get started. These 2 examples I have to talk about do not come from the textbook. They're examples that I created or found elsewhere. And I would really like for you to not only follow along with this video, but as you're completing this video, go to the Desmos activity for this guided study. You are going to be evaluating 2 derivative rules, 2 derivative expressions that look very similar to this in the guided study. Literally the same exact problems with the numbers a little bit different. So if you open up that tab, watch this video, and then rewatch this video with your problem next to you, you should be able to find these derivatives fairly quickly. All right, so we have the product and quotient rule combined. Now, since I'm telling you that, I'm going to go ahead and prepare myself to copy these rules because I know I'm going to need the product and the quotient rules. But kind of the first step in these is figuring out which one you need first. And what I recommend that you do is really look at and size up the problem. Here we do have a quotient. We are going to need to apply a quotient rule first. Okay, we have the quotient of 2 functions, 7x times e to the x, and in the denominator, we have that polynomial, x squared minus 2x plus 4. So carefully size up these problems. And as I always say, practice, practice, practice. The more practice you do, the more confident you will become in identifying what rules you need. And the more practice you do, the less of a surprise any problem can be on a checkpoint. So I'm going to write down that my f of x equals 7x e to the x, and that my g of x equals x squared minus 2x plus 4. Now, looking at g of x, that is a polynomial. I can differentiate this using 2 power rules and the constant rule. This is 2x minus 2. But looking at f, and this is where it becomes really important to be able to recognize the rules that you need. Finding f prime here, this is going to require a product rule. This is the product of 7x, a function of x, times e to the x, a function of x. So this is where the multiple rules come in. Okay, we have a quotient rule at first because we see a quotient of 2 functions there. So we're starting with a quotient rule. And then in the process of needing to find the derivative of f, we recognize that f prime is going to be a product rule. So, and again, I emphasize work organization. This is how I highly recommend that you organize this. Bring this to another piece of paper. Find f prime. F prime is the derivative of this blue function, f. But, and here's where this gets potentially confusing, because the product rule that I have written here has f and g again, but we've used f and g already. And I'll emphasize this a lot more in class, but for right now, just go with me. We have used the expressions f and g already in the example above. So if we're not careful and we use f and g again in this product rule, we could accidentally use the f's and g's from up there in our problem down here, and we want to not do that. So what I do is I rewrite my rules and I put little bars over the F's and the G's. I call them hats because I think it's cute and it's kind of fun to imagine putting little hats on your functions. You could draw like a little chef's hat if you wanted to. But for me, seeing a function f with a bar above it distinguishes it from this function f above that we're going to need in this quotient rule above, and we don't want to get them mixed up. We saw this in class, I think, actually, or you'll see this as you practice, right? The problem above that you were writing, that you were doing the chain rule for, had an f and a g. If you go on and move on to the next problem, but you use the function f and g from the problem before, you're going to get the answer incorrect. So for this product rule, I'm going to identify the function f with the bar as the first function in this product, and the function g with a bar as the second function in this product. And I'm going to just keep the bars, the hats, written on these functions. So when I differentiate f, I have f prime with a hat. F prime is 7 for this function f, right? We're finding an f prime so that we can apply it to the quotient rule. This is the f prime from the quotient rule. But this is the f prime for the product rule that we need to evaluate the derivative of the numerator of the quotient. And then I'll have g prime, but I'm going to put a bar over the g so that I remember that the bars, or the hat functions, are for the product rule. Actually, I don't want to end it yet. I want to now evaluate f prime. This is this f prime, and this is f prime for the quotient rule above. So that is going to be f hat times g prime hat plus g hat times f prime hat. These f and g's. That's 7x times e to the x plus e to the x times 7. So the f prime of x for the quotient rule above is 7x e to the x plus 7 e to the x. Again, this is an aside. This is on like a completely separate sheet of paper because, and I'm even going to, now that I've done it, put it on another piece of paper to get it out of the way of the quotient rule that we started. We found ourselves using the product rule to finish evaluating the quotient rule. We found the f prime function for the numerator. So this is for f of x without a bar in the numerator of the quotient rule above. And I encourage you again to pick up another piece of paper, write this on a separate sheet of paper, keep these apart from each other. Please attach your second sheet of paper in your solution when you submit your solutions, but that doesn't, I'm fine with that. I can follow it as long as you write aside and bring things where they need to go. So this is the f prime for the f function that was the numerator that required the product rule below. So now we come back to the quotient rule, and our final answer is going to be the derivative of this using the quotient rule. That is the bottom, the green function, x squared minus 2x plus 4. Forgive my dog in the background if you can hear him chewing on his bone. He's being a good boy. Times 7x e to the x plus 7 e to the x. That's the purple function. And then don't forget the subtraction, minus the blue function that we called f of x. But again, if you called this function down here f of x and not f hat, you might accidentally use that f in this blue function right here, but that's not the f you need. The f you need, the f function that you need is the function from the numerator of the quotient. And then times g prime. And that's all divided by the square of the denominator g, x squared minus 2x plus 4. And with these combinations of rules, follow the same guidance I give you for quotient rules in the beginning when we first learned the quotient rule. I do want you to simplify the numerators. And in this case, you got to be really careful because in the past, you might have learned the FOIL acronym. This is not a FOIL. There's 3 terms here multiplied by 2 terms. So we're going to have to multiply all 3 terms on the left by terms on the right. You see that? FOIL, first, outer, inner, last, relies on there being 2 in each. But here we've got a first, a middle, and a last. So we've got 3. You just need to make sure you get all combinations multiplied. And then over here, again, a lot of room for error in the subtraction symbol. So let's follow through with our multiplication in the numerator very carefully. We have x squared times 7x e to the x. So that's 3 x's, a 7, and an e to the x. Then we have x squared times 7e to the x. So that's a 7, an x squared, and an e to the x. Then we have a minus 2x times 7x e to the x. So that's a minus 2 times 7, 2 x's, and an e to the x. Then we have minus 2x times 7 e to the x. That's a minus 14 x e to the x. Then we have a 4 times 7x e to the x. That's 28x e to the x. And a 4 times 7 e to the x. That's a 28 e to the x. Now, all of a sudden, I've run out of space. And this can cause some trouble. Do not just go equals and then simplify, equals and then simplify. That equal sign makes it not true. You need to somehow, I'm going to try to make my writing a little smaller. Give yourself more space to finish out this problem. So now I'm subtracting, and then I have a FOIL, or actually I have a distribution here. I've got 7x e to the x times 2x. That's 14x squared e to the x. And then I've got 7x e to the x times minus 2. That's negative 14x e to the x. Now I'm going to transcribe my denominator. This is where the equalities are really important. Transcribe my denominator and then continue working the problem. When I emphasize practicing good workflow, don't just write this down and be like, oops, I ran out of space. Let me simplify it so I have more space. No, if you do that, you have to take it aside. Take it away from where you're at if you write that equal sign. Now, we have a lot of combining to do here. Instead of worrying about it and possibly messing this up, I'm going to rewrite it. Watch out when you rewrite it because you could transcribe something incorrectly by accident. I have minus 14x squared e to the x plus 14x e to the x, all divided by the denominator. Now, when you combine things, be really careful because they have to have the x term in common and the e to the x term in common. And we actually don't have any x cubed terms to the right. So we're going to rewrite that expression in the numerator and continue. Do we have any terms that contain both x squared and e to the x? We have that one. We have that one. We have that one. So we have minus 28 x squared e to the x plus 7. So that's minus 21 x squared e to the x. Then we have x e to the x, x e to the x, x e to the x with different coefficients. See how they match all x terms? And then this one's pretty basic, minus 14 plus 14. So we're just left with plus 28 e to the x, 28x e to the x. And then finally, our last one, we don't have to worry about combining with anything because there's nothing to combine it with. We have 28 e to the x, all divided by x squared minus 2x plus 4. For me, you may leave it like this. You could factor out an e to the x and then potentially factor the cubic. But I just want you, for the moment, combining those like terms and writing your answer down. All right, remember that you should be following along with the guided study in Desmos as you go. The example that you're going to see is going to be very similar to this with very similar numbers. So I highly encourage you, after you've watched this video, go into that question. Then your third question is going to be, or no, this will be your second question, is going to be a code word. Today, the code word will be blue butterfly. So in that little code word section, please type in blue butterfly before you move on to the next example, which is 2 chain rules. So I tell you, you're going to need 2 chain rules. So I'm going to go ahead and in prep, copy some chain rules. This is going to be the chain rule. This is going to be the rule I'm going to need. But how would I know I actually need 2 chain rules here? And this is where I encourage you to recognize what we talked about in class, that cube on the sign. I can rewrite this as d dx of sine of whatever is input in that sign raised to the 3rd power. And when you have an expression raised to a power, it's as if that expression is being operated on by that power, in this case, the cube. So yeah, we're going to need a chain rule to evaluate that, but I'm not worried about it right now because at first I'm going to go ahead and write down my outer function and my inner function. Again, I encourage you to write down that inner function first, just because, as I showed you before, you can mark that out and put an x there, and that expression will be your f, because this is function composition, right? Then start differentiating. F prime in this case is 3x squared. That's a straightforward power rule. But g prime here is the derivative of sine with something inside it. This is going to be another chain rule, right? Because, and I should have written it up here, and I encourage you to, as you're doing, I copied it and got it ready, right? This is a chain rule because there is an inner expression that's green there being operated on by an outer function, cube. Then again, you see that again right here. So take this aside. We need a second chain rule. So when I paste that definition to find d dx of sine of x to the 4th plus 2, that is g prime for the first chain rule, I'm going to put hats everywhere. F is going to have a hat, G is going to have a hat. F prime is going to have a hat, and G prime is going to have a hat, because that G prime and that G prime are not the same thing. And then again, we've got that same kind of problem. We have an inner function, x to the 4th plus 2, being operated on by a sine. And I encourage you also to, again, mark out that expression, put an x in the place of what you chose g to be. Write down your f of x and then your derivatives. The derivative of sine is cosine, and the derivative of x to the 4th plus 2 is 4x cubed. Now, notice that I didn't copy my hats. I'm going to go back and I'm going to put hats on everything, because I want them for the formula so that I don't get mixed up. And then I'm going to apply the formula. The derivative of G for the original chain rule is F prime evaluated at G times G prime. That is cosine of x to the fourth plus 2 times 4x cubed, or the final result of G prime is 4x cubed cosine of x to the fourth plus 2. And this is needed in the original chain rule. So all of this was aside for the original chain rule. Our second chain rule was aside for the first. So I did it on another piece of paper. So I'm going to transcribe the solution for G prime that did not have a hat in order to bring it back up here and complete my chain rule for the original expression. Now watch carefully here. d dx of sine of x to the fourth plus 2 quantity cubed is going to equal the chain rule expression using what we just found above with no hats. That is f prime evaluated at G times G prime. Or three times the quantity sine x to the fourth plus 2 raised to the second power times the G prime expression that required a second chain rule. When we combine this, we will go ahead and combine the 3, the 4x cubed, and just leave everything else as is. This is 12x cubed times sine of x to the fourth plus 2 squared times cosine of x to the fourth plus 2. If you want to be really concise, not required, you can bring that squared back in between the sign and what the sign is operating on. I would like to remind you that if this feels like a lot and you're not following what's going on, it's an important part of this process that you go back and review these quote unquote basic rules, right? We're combining multiple rules. You could combine the quotient rule with the chain rule. That's what you'll have to do in the example that's extra credit. I posted an extra credit example, an extra credit learning community point that you can submit this week and attain some extra credit. It has to be submitted this week. And again, it's a chain rule with a quotient rule together. If you bring that to class by the indicated date, then you will have some extra credit submitted for learning community points. And then I just want to encourage everybody one more time, tell you all that you're doing excellent work. Wherever you are in this process of learning rules of differentiation, you're doing a great job. Keep it up.